So we are already 7 weeks into the course, and we have seen multiple topics. We have seen SCML, databases, we have seen .NET programming, we have seen front-end programming using Angular and React, we have seen unit testing, we have seen DevOps, we have seen design thinking. So if I compare these set of technologies to at least one word, which is SDLC, which is software development lifecycle, there are multiple phases involved. Some say that there are 5 activities, there's 5 phases, some say there are 7 phases. But then for our discussion, we are going to limit it to only 5. There's a requirements phase, there is a designing phase, then there is development phase, and then testing, and the final phase is deployment, right? Uh, we've seen these 4 in the last 6-7 weeks, and now I'm going to focus my attention on the deployment front. So So how do we deploy our application, and then what infrastructure is required for that kind of work? And there are multiple challenges that you're going to face as you do deployment. In the DevOps session, we saw that a team runs into multiple conflicts, multiple transfer of the deliverables. So a developer is going to write code using a programming language like C#. It is going to give an artifact, a deliverable, which is going to be set of DLLs and executables configuration files. Those configuration files will be picked up by the QA team. They're going to test it. Then if everything goes through fine, the same package will be transferred to production, and production is going to copy it on specific folders on that particular machine. There is multiple machines that are getting transferred, and the biggest challenge that anybody is going to face is ensuring that the machine on which a developer develops the application, it is exactly the same as the production machine. A lot of times, the dispute between the dev and the production team is that the thing that work on a developer's machine, it is not deployable on the production machine, right? And some people must have heard this in the past, that the developer says that, hey, it works on my machine. And then the project manager, the deployment guys, they're going to say that, but we cannot give your machine to the client, right? And this is where technologies like Docker come in picture. Docker is going to help you build application in such a way that it is going to create a package, and that package could be transferred from one machine to another. But then to get to Docker, let's build a very basic case of deployment and what environments are. So what I have here is a Windows machine, uh, but then uh, this machine itself is pretty big. So if I show you my configuration, I have about 300 GB of hard drive. Right, on this machine, I have about 200 GBs of hard drive. There are multiple software that are installed, and in these software, they they are very specific, very native to my computer. Like I have a Visual Studio development. I have a Visual Studio IDE. I have database SQL Server Management Studio installed on the machine. But then not everything that I have on this machine, they are required for production functionality. Uh, Another challenge that people face in the production environment is that one server, it can only take so much load, right? There are, say, only 20,000 users that can log in. There are only 1 million users that can log in. And then this infrastructure is not going to be enough when the user load significantly increases. So when 10 million people log in to this machine, this is not going to be enough. In that case, the IT team, the operations team, will have to reach out to another team called the procurement team. The procurement team, they're going to evaluate as to by what number the load is increasing, and they are going to go in the market and reach out to different hardware providers and tell them that, hey, we need a server that can handle this kind of load. And then acquiring these servers, these network infrastructure resources, they are going to become a very long activity in itself. And then the way business is progressing, it is a need of the hour that our infrastructure, it responds to the changing load of the incoming traffic. We cannot spend, say, 6 months acquiring 10 computers that are enough for the load that is there. Imagine an e-commerce site like Amazon.com. Now, Amazon is going to see a spike in the users during sales time. Those sales time could be Diwali, during Christmas time, New Year's time. Probably there's a special sale that Amazon is launching to promote its vendors. The sale is very dynamic. If you're going to take 6 months to address that need, the sale is going to end by that time and you might not require these servers. So it is not just procuring these services, it is also releasing these services back. So the resources, the servers that you don't need, you want to give away to the organization's resource pool, and you want to operate on smaller frequency because maintaining this infrastructure itself is going to take a lot of resources of the organization, including money and then power, electricity, right? Stuff like that. So you want to have some form of control on how you go about acquiring that infrastructure. Going out in the market and purchasing these hardware, it is definitely not enough. And this is where technologies like virtualization, they become so important, right? We have seen in the programming class, V3, where we talked about .NET, that what we have is a microprocessor. And then this microprocessor is going to deal with a memory, some form of temporary memory, some hard drive, which is going to be a permanent memory, and we're going to store data like this. But the question is, these CPUs that we have, are they operating at their full capacity, right? Is there a way that we can optimize the working of these CPUs and use only a small chunk of the CPU that we want, right? If we can identify a deployment level that can divide our processor or resources on the computer in a way that is more granular, more logical, and it can be transferred easily, then probably we have solved part of the problem. Our problem is that Windows is a pretty big machine and I cannot transfer that machine. If I can create a system that can be transferred in the form of file, then I've solved part of the problem. And this is where technologies like Hyper-V comes in picture. Now, using Hyper-V, what we have here is a CPU, and on top of CPU, uh, we install an operating system. Now, this operating system, it comes with a lot of default functionality, like it's going to let you interact with the network. It's going to let you interact with the file system. So we can focus on other activities, and the OS is going to manage these three resources for us, probably more resources, like the network itself. On top of this, we install framework like .NET, and .NET is going to make sure that regardless of the operating system, we should be able to write application. Now, using .NET, we can build e-commerce application, we can build CRM application, and in the CRM application, the output that they produce, a bunch of DLLs and executables, they can be transferred on different machine and they can be executed. As a part of deployment, we are only going to focus on this piece here, right? We we will have to worry about the framework as well. But then this part of the installation, it is generally with the deployment team. And this part here is generally with the developers team. Now, as we switch from one machine to another, there will be differences on what packages are installed on the operating system. And then this delta here is going to cause a lot of trouble, a lot of confusion when we switch from one environment to another, right? Another thing about operating system, that an operating system is going to give you a, a projection of the resources that you have. So if you have, say, 16 GB of RAM, right? It is the operating system that is projecting that image to you. If we can create a software at the operating system level that can give you a different picture of what hardware resources you have. So suppose you have an 8-core machine which has 8 CPUs, probably 16 virtual CPUs. You have, say, I have 200 gigs of hard drive. if I can create a program that can give a different projection of the resources that I have, like I have one CPU, I have only 1 GB of RAM, and I have only 10 GB of hard drive, then the granularity at which I'm working of 200 GB and 8 CPUs and 16 GBs of RAM, that granularity can be controlled. And if I manage to deploy the executables on that particular part of memory, then I have solved part of the deployment problem. I'm going to pick up this projection or this projection like setting along with the local resources that it has, like the RAM and the CPU. I'm going to pick this thing up and I'm going to transfer it to a different machine. And then because it is a different type of hardware or operating system program, it is going to perform that way. So once this technology is Hyper-V, and using Hyper-V, you can create virtual machine. Now there's an option called Quick Create. Quick Create has multiple out-of-the-box virtual machine installation. I've gone ahead and I've created this machine. If you create on this, it's going to create the default Ubuntu 18.04 version. I've gone ahead and installed that already, and it is up and running here. Before we jump to that, let me go ahead and click on this little settings button here. When I click on the settings, notice that I see firmware, I see security, and I see memory. Now I know that the memory of my computer is way more than 2 GBs, right? I know that I have more than 4 virtual processors. The hard drive that I have, it is it is a network physical thing that is installed on the laptop from which I'm showing you the demo. But then when I select hard drive here, what I see is a network location. So let me go ahead and copy this. Probably I can browse. Right. So it has gone to another drive on my computer inside the Hyper-V folder, and the name here has changed from hard disk to virtual hard disk. And then this virtual hard disk itself is about 4.5 GBs, right? There is another AVSDX file that I don't understand what it is, but I think it is related to some form of virtualization of hard disk. What this software essentially is doing is that it is picking up resources from my computer and it is creating a projection of those resources, and it is giving me an option of using the limited resources from the actual physical system, right? Because it is an Ubuntu operating system and then my host machine is a Windows machine, it is giving me the flexibility of changing this layer as well. Now, I'm not restricted to Windows 10. I can switch to a whole different operating system, right? What we saw in these programs that there are pre-stable, there are AX, BX, CX, DX registries, and it is a kernel level program. This kernel level program is giving you access to the physical hardware resources mounted on the motherboard, right? A special program running almost at the same level as the operating system, it can give projection of what physical hardware you have. And then if I install .NET on this piece, the application that I'm running, say e-commerce or CRM application, it is going to think that I have only one CPU and 1 GB of RAM because these applications, they have no way of identifying on what hardware you are running. So let's go ahead and try to connect to this virtual machine. I'm inside the Ubuntu 18.04 version, and when I go outside, I this is Windows. So there are two words here in discussion. Number one is the host operating system, which is the Windows operating system. The second is the guest operating system. But then for the guest operating system, which is Linux in our case, for that to work, we require a special software. Now, a hypervisor is going to work almost at the operating system or the kernel level, and everything that the operating system can do, um, the hypervisor or virtualization technology will also do. In fact, what I recollect is that it also takes away the ability of booting from the operating system. But then let's table the discussion on virtualization aside. The concept that we are discussing is that it is possible to create a small projection of the actual resources of your system and project something else. right? Like 4 CPUs, 1 GB RAM, and 10 GB of hard drive. On top of this thing, we are going to install different operating system. And on these operating system, now we can go about installing our different software. So if I type .NET, there is no .NET installed here, but then it is giving me a nice handy command that if I run this command, it is going to go and install. So the options are not going to work. I think it is control insert that copies it and shift insert that pastes it. And then it is asking for my root password. If I enter that, it is going to go to the internet and it is going to try to download that software, right? And then there is some error, right? So now imagine what would happen if you tell a deployment guy that go ahead and install .NET on the production server and then um, copy my DLLs, my EXEs, and it should work in production as well. But then the first command itself is giving you an error. And then we are not only limited to .NET and e-commerce and custom application. There are multiple different applications that we can have. We can have a database server like SQL. We can have some caching technology like Redis. All of these um, software, they need to be installed first, at probably at the framework level. And then on top of this, you're going to do your customization. This established that creating the machine itself is challenging. Installing the software is difficult as well. Now, let me go ahead and launch Google Chrome, and I'm going to say .NET Hyper-V PHP. So people have gone ahead and they have created virtual hard drive, a file like this for most of the technologies that we are going to work on. So what I was trying to search here in this window is one such hard drive. I'm not finding it, but then people who have worked on SharePoint, they are going to be better able to connect with this. You create a virtual machine. On that virtual machine, you create a SharePoint image. Once you have that virtual hard drive file, you can pass on that virtual hard drive file to different developers in the team, to QA, to the production environment as well, and that VHD is going to work. So let's see if there is a VMware VHD for SharePoint, right? And then the technology provider, they are going to provide those files to you. I don't know. So if you don't want to use this, I was looking for that one file, which is going to let you download a 10 GB file that you can copy on your computer. And if you paste it in a folder here, it is going to boot up a machine with SharePoint installed on it. Make sense? But here's a problem. In a production environment, you are not going to have uh, one SharePoint machine, right? You're probably going to have 10 SharePoint machine. And then this is where virtualization, it becomes costly. If you have these machines, our intention of having this is that number one, we want to optimize the hardware resources. Number two, we want to solve the problem of deployment. We want to have consistent deployment experience across different environment. And the only thing that we care about is this layer here, where our developers are contributing, right? The rest of the system, it is fairly constant, right? That one database machine is not very different than another database machine. If I go on creating multiple VM like this, I will have to install the operating system multiple times. And then what we have already seen is that machine itself is about, in the settings, is about 5 GBs, right? This hard drive. So if I want to have multiple instances of SharePoint, this machine is blank right now. It has only operating system, and then it is already 5 GBs. Imagine that you were doing deployment on Windows Server 2012. This file is going to be a lot bigger. And then the only thing that is going to change between these 10 instances of SharePoint is probably this layer, probably, right? It could be same as well. So we have found part of the solution that projecting network resources through virtualization is effective, but then there are multiple duplication of activities that we'll have to do. So if we can use the operating system in a better way and just figure out a way of changing the layer that developers touch, then it is going to be more optimal. And this is where Docker comes in picture. So we have two options here. One is virtualization, and second is, okay, so I'm not going to call it Docker. I'm going to call it containers, right? In virtualization, what happens is you have a layer of hardware. On top of hardware, you have the host operating system. In our case, it was Windows. On top of host operating system, okay, I'm going to draw it on top of the host operating system. It is going to be a little different in reality. A virtualization framework. On virtualization, on top of this, we are going to have multiple VMs. And then each of these VMs, they are going to have their own set of these things. So it is going to have its own set of hardware, and it is going to have its own operating system. And then on top of this operating system, you're going to have different frameworks. And then this thing is going to repeat. So hardware, OS, and framework. Hardware, OS, and framework, right? Uh, and framework. Because of this repetition, it becomes a little ineffective because we saw the example of Ubuntu, which is a free source. But then imagine that you have a Windows operating system, a Windows server technology. You will have to buy licenses, right? And you'll have to keep paying licenses for these because you are installing it on multiple machines. Containerization is a technology that is going to provide you, I don't want to use the word virtualization, it is going to let you use operating system resources a little differently. So the first two layers, they are going to be the same. There'll be hardware, there'll be operating system. On top of operating system, you will have a container, right? A container, if I zoom in on this, is going to have the framework and it is going to have the custom code. So I'm just going to say that it is e-commerce. So .NET, on top of .NET, I have a C# application that is building e-commerce. Everything that is required to run this container is part of this image file. And then this image file is going to run on the operating system, right? So we have eliminated um, multiple operating system installation and multiple framework installation on these machines. We are going to create one simple file, and this file is going to give the same effect of a virtual machine. It'll have the ability of projecting the hardware a little differently, and it is going to rely on one operating system that you have installed. Now, containerization technology is only available on one operating system, and that is Linux and all the flavors of Linux. And the way Linux does this is there are two important concepts here. Number one, C groups, and second is an isolated environment technology. I'm forgetting the name. Give me 1 second. Namespaces. And the second is namespaces. Now, the reason we wanted, so let me go ahead and make a case for virtualization even stronger. Uh, there is this legacy application that is installed in your organization that is still using Windows Server 2003. Now it is almost 2 decades that Windows Server 2003 was released, and there is one application that part of your team uses, and that application has about 100 users, right? Because of these users, there is an entire server that we are maintaining, right? This server here only for 100 users. And we don't want that. We want to decommission the server and figure out a way of not having extra hardware maintenance just for these 100 users. And this is one of the cases where virtualization started to shine well in the past. This is how it entered the market, that you don't have to go about maintaining different infrastructures. You can create a virtual machine, and that virtual machine for this load is not going to acquire the physical infrastructure. It can be tugged on other infrastructure that you have, and this is where those 100 users or those applications will be running, and you can decommission the old servers, right? So it was part of, say, IT cleansing in the organization. Now, uh, the application, this application probably was using .NET version 2, right, or .NET version 1.1, right? Pretty old, but there is still usage and there are still users of this application, so you just cannot give it away. The latest version probably of .NET is .NET 5, .NET 6 in the preview version, and we want the flexibility of running these two .NET frameworks on the same operating system. With .NET, it is possible. Some other technologies might not allow it, like having SQL Server 2017, 2019 on the same machine probably is not allowed. MySQL multiple versions, they are probably not allowed. And uh, they solve this problem using virtualization, but then virtualization will require another line of operating system. So containers, they would say that, you know what, build an application, build an image file, and that image file is going to have all the dependencies that is required for running that application. And then the operating system is not going to care about what version is running inside that thing, right? The OS is just going to hook into this container application, and it is going to let you run multiple versions parallelly on the same operating system. So if we can drive an analogy to this thing, let me go ahead and pull up a nice picture, right? This is probably a screwdriver, but then depending on what type of application you want to run, all you have to do is you have to replace this particular attachment and put it this notch, and it is going to fit right in because they all need that structure, that dimension. And then you can use this lever to open the type of nut or screw that you have. Now, this is very close to what operating system does or what container technology does. The resources that you have, this handle here, this lever here, is the operating system. And then everything that you require for interacting with the external world, it can be replaced as an attachment on this particular thing. And then on the same infrastructure, on the same hardware and operating system, you can perform different activities. It doesn't care what you have. It just gives you that interaction point. And the way it so this is a physical system, this is an analogy, but then in the software world, the way it is going to maintain that thing is through namespaces and C groups. Inside the Linux operating system, when there is an executable that gets loaded for execution in the memory, the operating system, it assigns these two um, type of resources to that particular executable. So an exe is going to have special tagging, and then those tagging is going to be part of namespaces, right? Based on these namespaces, we can differentiate between .NET 1 and .NET 2 and .NET 5. .NET 1 is going to come with its own set of namespaces. When when the Linux operating system finds out that this particular exe is saying that it belongs to this particular namespace, all the resources that the operating system is going to allocate to that particular application, it is going to draw a boundary around it, right? Now, if we say that, hey, I want to save a file on the slash user directory, right? You would have no way of interacting with the directory structure of this particular application, right? They would have absolutely no view of the hardware that is allocated for the execution of this particular program, right? So namespace is going to create, let me type that. Namespace is going to create an isolated environment, pretty much what virtual machines were doing as well, right? They were taking the entire hardware and through virtualization, it was giving you a different projection. Linux does that at the software level, and it does that using the first concept, namespace. So when you want to do a demarcation of what resources are available, you're going to create namespaces. Another important concept of containers is C groups. Now, C group is similar to creating this picture here, that how much CPU, how much hard drive, and how much RAM, and how much network resources you want to give to that particular application. So C group is going to talk about resources like 1 GB and then 1 MB of RAM and say um, only one CPU, right? So C group is going to control the hardware allocation. Namespaces, they are going to draw a boundary around these allocated hardware. So inter-application jump is not possible, right? You have that segregation that one application cannot access the resources of another application. And that is container technology, that we are going to create a file that is going to use the C group and namespaces feature of the Linux operating system. And through this feature, we will be able to create isolated environment, allocated limited resources. And inside this boundary, we are free to run any application that we want. And the most similar analogy that I can think of is having different attachment to a screwdriver, right? We have this solves the problem of duplication of virtual machine. The other problem of virtual machine is that they are they're going to they're going to consume a lot of resources, and once again, this installation is going to be very typical to that particular machine. So suppose you give a package to a dev machine, to a QA guy, and he's not able um, to get the software, get the application running. They are going to do their own custom installation. Remember that original question that we said that we cannot give your machine to the client? We want to change that definition, right? Now we are going to enable the developer and we are going to create a small machine that runs on the developer machine. And because it runs on developer machine, we are going to pick up this exact thing and we are going to pass it around to through multiple phases of SDLC. And this is going to enable that easy software deployment. So remember from our DevOps session where we talked about CI and CD and CD and CM, continuous integration, continuous deployment, continuous testing, and continuous monitoring. So we will be able to make this part of the pipeline that as soon as the developer is finished writing code, he's going to create a new image, and this image is going to become part of the deployment pipeline, and it is going to progress from, say, dev environment to QA environment to production environment, right, automatically. So this is the thought process of containers. I am not going to try and install .NET here, but then if you are interested, go ahead and figure out how to install. The keyword in the Linux operating system is EPT. This is very similar to what we saw in Node example, NPM, and this is very similar to what we saw in the .NET example, .NET NuGet, where I'm so sorry, it's not .NET NuGet, it is .NET package, that we go on the internet, we figure out a package name, and then we install that package name here, like Entity Framework Core, and the DLs are going to get installed. So at the operating system level, there's a command called apt. If you run this command, it's going to give you multiple options. apt update is going to update the package itself. It is like running npm install-g npm, and it is going to install the latest version of npm. And this update is complaining that I cannot delete it. Putting sudo in Linux, it elevates your privileges. And through this, you are going to get a list of all those packages. and then giving it the right package name like Ubuntu and Docker and Kubernetes and Node, it will go on installing those packages. It will add those packages to the machine. Now, I don't know. Okay, I was thinking of talking about instructions like commands for creating environment and uh, expecting the environment to get created through configuration, like commands and configuration. They are two different concepts that is becoming popular in hardware creation. But then we're going to table that discussion till we jump into Kubernetes on Thursday. So for now, you can use apt and install .NET on this machine, and eventually you will be able to run command like this .NET, and it is going to show you that help where you can do .NET New, .NET Build, .NET Test, .NET Deploy package. All those options will be available here. We are not going to do this. Instead, we are going to use Docker itself. Now, to install Docker, I have multiple options. You can go to Docker and search install. It is going to take you docker.com pages. And depending on the operating system that you want to run Docker, you will have to find out the right package. Probably I'm going to see something for Windows. For Windows, it is saying that go here and you can download Docker Desktop for Windows. Now, if you've been in my session before, I am not a big fan of custom downloading these executables. I don't like exes installed and manually installing things. I am more of an automation guy. I'm going to go to Yoko and I'm going to search install Docker. And once again, this is going to take me to an installation script. Sorry, I want to go to this side here. It is downloading almost the same version, I guess. So if I do J, it is going to say it is not printing any version information here. Anyway, but then this command here, choco install Docker desktop. If you run it, it is going to install the version 3.5.2. And that version, when installed successfully, it is going to run in the taskbar and it is going to look like this. Right? It is showing the images that I have, it is showing the volumes, it is showing the environment, and it gives you multiple settings as well through which you can play around. Now, once again, if you are anything like me, we are not going to use tools. We are more about commands. And after successful installation, if you run this command, you're going to see Docker. If you run this, it is the Docker CLI, and it's going to give you the option of interacting with the Docker operating system itself. So you provide set of option, and then you pick up a command, and then there are these many commands, right? Um, Rest of today and tomorrow, we are going to see multiple of these commands, and we're going to see how Docker is enabling us in creating that little container image that can be transferred across different machines. So it is printing a nice a self-sufficient runtime for containers, right? The technology name itself is container. Docker is a tool. Um, with that said, we saw on this tab here that Docker is running on Windows. This is not entirely true. You cannot install Docker. What we discussed here in the whiteboarding session, that containerization is possible only on one operating system, and that is Linux. Flavors of it is available for Windows, but then mostly containerization technology is a Linux-based technology, right? When somebody says that I'm doing Docker on Windows, the process itself is two phases. Number one, you're going to have the host operating system, which is Windows. By the way, this goes for Mac as well. Unless you are like on Ubuntu, you're not doing virtualization, or you're not doing containerization. When you install that tool, this tool is going to create a virtual machine. And this virtual machine is going to be a Linux-based virtual machine, right? And all the container application that we write from this point onwards, like the .NET application for CRM, we are going to write on that virtual machine. This tool here, it is only going to It's going to give us a projection that we are interacting with the Windows operating system. We are not internally in the background. This tool is running a virtual machine, and all the interaction, all the activities that we are doing with the application, it is with this virtual machine that we are going to do. And this is where the Docker architecture comes in picture. So there are three pieces to it. Okay, the first piece is the Docker client, the CLI that we are interacting with. The second piece is the background process. So it is a daemon process, and it's called Docker D, I guess. I don't remember the name, Docker D. It is going to run in the background. And when we tell Docker that, hey, Docker, can you run .NET for me? It is going to go, it is going to pick this thing up. It is going to do an API integration, API call to this Docker daemon process. This Docker daemon process is going to figure out everything that is required for running this .NET application, and it is going to execute that thing on the virtual machine, right? So there's a third piece that I'm not going to talk about right now. We're going to table that discussion for a little bit, and then I'm going to then I'm going to show it to you. So this is Docker architecture. Let me run through my list of activities. All right, so we were in the command prompt, and let's look through these command line options. So there are management commands, and I see Docker container, I see Docker context, Docker image, Docker network, node plugin, secret service, stack, swarm, and then there is another set of command which is in the category of commands. So there's an option called command attach local standard input output and error stream to a running container. Okay, so we can probably connect input output devices to the container that we are going to create. There's a Docker build an image from a Docker file. We don't know what Docker file is. There's a CP command. CP in Linux is for copying, and probably I'm hoping that it's going to be the same functionality. Copy files and folders between container and a local file system. All right, so that makes me bring another point to discussion, that this is the Linux operating system that we have, right? I would want flexibility of transferring files from my local machine to this machine. And then this is where the network setting or networking between the host machine and the guest operating system, it becomes important. And if you skim through this, you're going to see multiple networking options, that there's a default switch, and these two machines, they are on the same network. Just to prove my point, I'm going to try and see the IP address of a Linux machine. Now, IP space ADDR is the Ubuntu command for uh, for getting the IP address. I think there is also something called an ifconfig that also gets you. But then notice that because this package is missing, it is telling you that use apt install and nettools, and it is going to get you ifconfig. But we already have the IP address from here. Now I cannot probably do control insert for copy and see if I can ping. Sorry, if I can ping. And because I'm able to ping, there is a network path that exists between the Windows machine that we are on, this machine here, and this guest operating system of Linux. Now, RDP is a remote desktop protocol, and I don't know if there's an easy way of doing a remote desktop into these machines, but there is something called as SSH, which is a remote shell. It is equivalent to the remote desktop, the RDP connection of the Windows machine. If I give an IP address here and the guest operating system, if this operating system here was Windows, I'm pretty positive that on clicking this connect button, it is going to show me a login option, and it'll let me in the machine, and then we are going to see a user interface of this form. So that happens on another protocol called RDP. In the Linux world, the option is called SSH. It stands for Secure Shell. And to a secure shell, I can once again give an IP address, and it should let me in. But this is a service that needs to be installed once again at the operating system level. So there's a command for this that I'm forgetting. I think it is systemctl and status and SSH. And because it is an admin command, I'll have to run it with sudo. And it is saying that this service is not installed. Now, once again, I can use apt and install the missing packages and activate secure shell. Once I activate that, I will be allowed to do a remote desktop into that computer. And then through this console, I have I would have I can remote login to this operating system, and the commands that I run through this shell will be executed on this particular computer. Now we are coming from the stack here where we are trying to copy. Through Secure Shell, you will be able to transfer file from the host operating system to the guest operating system. Because there is no guest operating system, there is an image. If you want to transfer file inside image, you're going to use the docker cp command. You can create a container using docker create. You can inspect differences. There is event, there is exec. Exec is interesting. Run a command in a running container, right? I'm going to show you an example of this. This is very interesting. Then there is Docker images, there's Docker import info kill. Okay, looks like if you are not happy with your container execution, you are going to execute this command. There's Docker login and logout. This login and logout has nothing to do with what we discussed here. All right, this login and logout is the answer to the third question. All right, we are once again going to table it for now. There's Docker pause. You can pause a running container. There is rm, rmi, run, save, search, start command, stop command, and stop probably is a little merciful than kill. Kill one or more running container, stop one or more running container. So they sound synonym. They have different objectives. All right. So of the command that I see here, I like the run command. Run a command in a new container. Let me go ahead and run a couple of commands inside this Linux operating system. It is asking me for an upgrade. I don't want it. It might be later. And I'm going to run the ls command. Now ls is a Linux command and it's going to list down all the files that you have. If I do ls minus l, it is going to do a detailed listing of this. If I do ls minus l and pass it another option r, it is going to do recursive. Probably capital R is going to do recursive, and it is going to go inside all these folders inside this listing, and it is going to list the files that are present inside that folder as well. So ls is a Linux command. It lists the files in the current directory. The reason I'm showing you that is because I'm going to run a Docker command and see the inside of the Linux operating system. I'm going to hit Control L, clear the screen, do Docker run, and I'm going to say hello-world. Now, notice the output very carefully. It is saying unable to find image, hello world, latest. I did not specify latest locally. All right, so it did something. It said that latest, it is pulling from library, and it printed a hash, and then it said pull complete. Right, and then it printed a digest key. It said that the status download newer image for hello world latest, and then it is printing an output. And if you read through this output, it is going to say hello from Docker. This message shows that your installation is complete. Looks like an output of a console application. And then in the end, it is giving you a URL. There's a website, Docker Hub. If you forget the name ever, you can do Docker Hub if you don't remember the URL, and it is going to take you to the same URL that we saw in the output of the Hello World program, of the Hello World Docker container. If I go to this website, and observe it is going to ask me to log in, not sign up. I'm not a robot. I'm going to say sign in. All right, so I'm still on hub.docker.com, logged in with my account. And what I see here is Nginx, not something that I'm familiar with, or probably I have introduced in this class. Then we see Mongo, MongoDB. We already saw Node. We already saw Redis. Uh, we did not see Postgres, but it's a type of database. We know what Python is. We saw CouchDB. We do not see Couchbase, and there are other similar technology name that we see here. If I follow through this link and I click on see all images, it is displaying different filters and it is displaying list of different container image name. This is a third piece, right? When you want to run a Docker image, you are going to execute the command docker run. You're going to give it the image name. This image name on a network call, it is going to go to docker d, the daemon process. The daemon process is going to look for that image. When that image is not present, it is going to say that, hey, the image that you're looking for, it is not present. Let me go ahead and find that image for you on the internet, right? And then it is definitely going to come and go to this site and it's going to pick up that image from there. Let's just go ahead and search hello world because we did docker run hello world, and that hello world is over here. It has more than 10 million downloads. And if I go inside this, you are going to see a very similar command. We did docker run, but then it is saying docker pull. And it is saying that if you do docker run hello world, it is going to print this output. And then it is giving you another command, docker images of hello world. So let's go ahead and run this command in our application. So I'm going to do docker images. I'm going to hit enter and I see a lot of images. I see Ubuntu, then I see something for K8s. I have an application for e-shopping, e-commerce site, which has multiple images. The image that we pulled sometime back is the hello world image. This looks like version. This is a hash, and then it was updated 4 months ago. And the size of the image itself is 13.3 KB, right? Now compare these 13.3 KBs once again to the 5 GB of hard drive browse, right? This file here is 5 gigabytes, 4.5 almost, right? But then for running a hello world, what we created is 13.3 KB, right? If I wanted to do hello world inside this, I will have to install .NET itself. And then that command is going to require the entire operating system, installation of .NET, and then development, probably figuring out where to get that DLL from, and then running it on this machine. Docker container, it makes it extremely cheap of running the application. And this is where containerization technology, is it finds its application. So virtualization is still a technology, it is still required, but then for deploying application, if I don't have to create a 4 GB, 5 GB file, which is a VSD file, and pass that file around, if somebody gives me an option of creating a 10 KB file, I would be extremely happy about that kind of solution, because we have finally reduced our discussion to this point that one operating system, I can give it different container images, and those container images, they are going to have everything that is required for running the application, the framework, the code, and it is also going to have the projection of the resources, right? And it is just going to integrate with that operating system, and it is going to run that application for us. And if I have the requirement now of this, that I want to increase the infrastructure of my application from 1 million users to 10 million users, and I want that to happen really quick, I don't have to pass around a 5 GB file. I can pass around this container image file, and that container image file can be extremely small, and catering to this requirement from the physical world, which is going to take 6 months, to a virtual world, which is probably going to take 10 minutes, it can be dropped to less than a millisecond. Right? I can run multiple instances of this Hello World application, and it is going to scale up and scale. Okay, scale up is the wrong word. It's going to scale out and scale in to meet the need of the infrastructure or load from the application. We looked at the SDLC, and for for this week's discussion, we are going to focus on the deployment phase. We identified that creating deployment for different environments is very challenging. Acquiring resources is very challenging, and you might have a small application that is not getting used by many people, and virtualization becomes of great value here. That on an existing infrastructure, you can create a virtual machine that is going to take care of that small application, and then you can decommission the old retired infrastructure of the of the system. Uh, the only problem with virtualization is that you require multiple operating system installation, and the resource use wastage of a virtual machine is way higher. If we utilize the containerization technology of the Linux operating system, we can create better projection of the system resources through Linux concept of C group and namespaces. C group is going to create hardware level allocation, and namespaces, it is going to draw that boundary around those allocated resources so that different application can keep running on the same operating system and use the same resources without any overlap. So it is going to create an isolated environment, and no two applications, they are going to overlap with each other. But then we installed Docker on Windows. Um, Docker on Windows works through a VM that is obscure, that is hidden from the end user, but then it is internally using a Docker VM. And then on this Docker VM, we can call different commands, and these commands, they are going to execute the application. Uh, there are three entities at least in the Docker architecture. One is a CLI. CLI, we are going to interact with the Docker command, and we are going to give it different commands and management options to interact with a Docker daemon. The Docker daemon itself listens on a REST API endpoint through the Docker CLI, and this is where the actual weightlifting happens. When an image is not present, it is going to go to the internet. It's going to pull that image, and it is going to run on that machine. And uh, this is a central repository. It is called the Docker Hub. This is for the community version of Docker that we are running. There is another version of Docker, and that is Docker Enterprise. Docker Enterprise has more option, and it is more suited for organization that don't want to put their images on the community project. They don't want to put it on the internet, so they can set up their own private Docker hub, and with the right settings, instead of this Docker daemon going to say hub.docker.com, it is going to go to the hub of the enterprise. It is also available through Azure. It is called Azure Container Repository, and it is short for ACR. Or the other way, the ACR is short for Azure Container Repository. So you can configure Docker to pull images from the community Docker Hub website, or from an enterprise, or from any other container registry that is local to that particular environment. Before we went on break, we also saw example of Docker Hello World. Docker Hello World, because the image was not present, it downloaded the image, and then it executed the program, and that program looks like this. Now, uh, there are multiple images that are present. So if I go back to Docker Hub and look at this screen here, or Docker Hub containers, we want in the Explore link. And then over here, if you see that there's Oracle and MySQL and Ubuntu, there is another image called BusyBox, which is used very frequently. So I'm going to do Docker. Instead of run this time, we are going to do Docker pull. So let's go ahead inside Docker BusyBox, and I'm going to copy this command. hit Shift Enter, and I'm doing Docker pull. It is saying that the tag is latest. If you don't specify anything after the colon sign, it is going to default to the latest tag. And it is, you saw that little extracting. It is downloading that particular image on our machine. And now the machine itself is available to us. Now, if I read through the documentation, it is going to say docker run -it -rm and busybox. And there is another file that is creating. I'm going to run a different command. If you remember seeing docker exec in the documentation, I'm going to type docker. Okay, I'm going to say docker run. Then I'm going to say busybox, and I'm going to type echo and hello world over here. And look at this output. Let me run another command, docker run busybox, and I'm going to do echo. And this time, okay, let's not do echo. Let's do ls. And ls is giving us a directory listing. But then this directory listing is a little different than what an ls command output looked like in the Linux operating system. It had different structure. If I do ls minus l, it has different structure. Now let's go ahead and do ls minus l. And it is displaying this information here. Let's go ahead and so to launch a shell inside Windows, inside Linux, the command is bash, and bash is going to launch a new shell. Because we are already inside a shell, we are not seeing any effect, but because this is the shell, so we have duplicate shell inside a shell. And now if I type exit, it is going to exit to this shell, and if I type exit here, it is going to end this window here. It's going to kill this window here, right? So bash is for launching the terminal or something that we can interact on pass command line arguments. So I want to launch a bash, and when I do this, I don't see any effect. It is saying the error response from Devon, the runtime created file starting container process bash, executable file not found in $path. Let me go ahead and see if that option is available. All right, and once again, the same error. So the busybox image that we created, it has an implementation of ls command, and it has an implementation for the echo command. It does not have the implementation for bash, which is for launching shell. So I cannot go inside this particular image. Let me go ahead and do docker run, and this time I'm going to do Ubuntu. Now, okay, it did not do anything. And this is where I'm going to show you another command. So drawing parallel between the Linux operating system, if I type ps here, it is displaying bash, which is this terminal, and it is displaying ps. So any application that is running on the operating system is listed inside Linux operating system using the ps command. It is equivalent to task manager of the Windows, and it is displaying PID. And if you compare it to this output here, it is giving you a PID here as well. Inside Docker world, there is a command available, which is docker ps. If I do docker ps, it's going to give me a listing of the containers that are in execution. And right now it is saying that there is nothing in execution. There is another option that I can provide to the ps command, and it is docker ps-a. When I run it with -a option, notice the output. We ran the Ubuntu command some time back. It did not do anything. But then if you read through these headings, container ID, image, then the command itself is bash. It said it created about a minute ago, and then it exited 59 seconds ago. So probably it ran for like a second, right? There's something called as ports. Then for busybox, when we did bash, it exited, it did not do anything. But then we ran busybox as an operating system. And we ran the ls-l command, we ran the ls command, we ran the hello command. Then before that, we ran the hello world program. So it is a listing of all the container execution that happened and the image name that we used. The image name is coming from this Docker Hub website that the image name itself is listed here. What Docker does is it launches this container image and it runs it on the operating system. And then when that program completes, it kills the operating system. So what we have to do, we have to figure out a way, because probably we are going to build something like a server application. That application is going to up and it is going to start listening on, it is going to keep running in the background. And to do that, we are going to pull another Docker image. I'm going to say Docker run. And this time I'm going to pass two options that I'm going to explain very shortly, -it, or let's go ahead and do -help and see if those options are listed here. So I'm passing -i, and -i is for interactive. It says it keeps the stdin. If you've done any C programming, you would be familiar with this. This is the standard input stream, open if not attached. And then I'm passing the second option of -t, which is TTY. It is a type of interactive device. So the screen, it can be assumed to be a TTI. So I want to interact with the, uh, I want to connect, attach input output devices. So that is -i. I'm so sorry, that is -attach. -i is interactive session where you can interact with the device. I can also type -interactive. I'm going to short for -i, and I can type TTY or -t. I can put them together. And this time I'm going to say Ubuntu, and I'm going to pass a command that I want to launch when this image starts, right? Now when I hit enter, all right, notice that my prompt changed. It is, it has changed from my Windows-like interface to a more Linux-like interface. This is the output of an SSH. And now if I run the ls command, it is, we are seeing a different output. Right? I'm going to launch another window. And on this window, now I'm going to execute Docker PS, right? Because our process has not exited yet, we are seeing an entry nps without the -a flag. These are all the running containers. -a is going to list the container that started and they ran to completion, and they're not running anymore. The ps command is going to display the Docker container ID. It is going to display the image name, and it is also going to display the command here, the command with which we launched the application. And then we launched this application with the bash command. And this is the part one of creating these container images. So far, we've been saying that a container image is going to be available on the Docker Hub. We're going to pull that command. We're going to pull that image. That image is going to perform some activity and it is going to run to completion. But then you want to have some form of control. So throughout the rest of the session, we are going to look at this particular image, and we're going to add multiple pieces to this. This last block here is called CMD, or sometimes it is called entry point, right? Uh, what we are doing is we are creating, okay, I think I can tell you one more analogy. What is the difference between an exe and the task that we see in the taskbar? Right? An exe is a file, right? It has a different extension, it has a different format, but then there's a lot of binary data inside it. And then this data, when the operating system puts it for execution, it goes in the processor and does specific activity. But then the exe itself is a file, right? A PID is a process. Now an exe becomes PID when the operating system executes it, when operating system schedules it for execution, and there is a process created at the processor level. Container images, they are very similar. When we ran the docker pull command, we requested for an image file. All right. So this container image is a file, and in this file has all the dependencies that it requires for execution. So it can have .NET, it can have SQL, it can have Python, it can have all the dependencies that are required. And that's what we discussed in this section here as well, that there's going to be default operating hardware and operating system layer. And on top of that, we are going to create a file, and that special file is going to bring all the dependencies required for running that application. We saw example of hello world, and when we ran hello world, it printed some default output on the screen that if you're seeing this output, your Docker installation is successful, right? And then it pointed multiple links. It is like writing an exe with 20 printf statement, right? And then these printf statement, they are eventually going to generate that 10-line output that we saw on the console. Make sense? So hello world itself is a simple executable that has multiple printf statement. And when we say docker run, it comes and it executes this particular command here. But then this command is a little flexible, right? If it is created with the option of entry point, we cannot change it. But then if it is created with the CMD option, it can be changed. And all right, and when we ran the docker busybox ls command, that's what happened. We excuse me 1 second. All right, so when we ran the docker run busybox command, we went to the Docker Hub, we pulled out this image, and to this image, we told that when you start, I don't want you to run the entry command. I want you to run the ls-l command. The first time we ran it, we told it that don't run your default command, run the echo hello world command. So this busybox image, it is giving you the flexibility of the command that you want to launch, right? Let's see if we have that flexibility with the docker hello world command. So I'm going to do docker run hello world, and I'm going to do ls here, right? And it won't let you do that. Uh, if I try other option like echo 123, it is not going to allow you that, which indicates that docker hello world is not flexible in changing the command that is executed when that container image is given for execution to the operating system, right? So there is there are ways in which we're going to see in the future part of the session where we are going to create this docker image, and we are going to generally end it with one of these two commands. The ubuntu command that we ran on this window here, it was created with the cmd option, and we ran bash. It started bash for us, and because bash is an interactive shell, we had to provide these options that, hey, when you launch this program, I want my keyboard and my monitor to get associated to that remote machine, and everything that is getting generated as part of running this output and as part of running this image and this particular command, all the keyboard interaction from my host computer, from the Windows machine, it should go and get executed inside this particular container image. So we are interacting with a program that is running on a different side of the application. And now we are interacting with that little virtual image. It is like launching an entire operating system and doing a remote desktop inside it, right? We don't need this level of sophistication, this big file. We can create a small image for Ubuntu and launch a shell of its own. And now that we have the shell, we can do multiple things over here. I can run the ls command. I can run the echo hello world command. I can probably see if there is .NET available over here, and .NET is not available. So let's see if there is apt available. right? And apt is available over here. Now, if I figure out a way of installing .NET, I'm going to say docs Microsoft install .NET on Ubuntu, right? It is going to take me to the Microsoft documentation. And over here, I'm going to find a bunch of commands. So we are already in the Ubuntu section, and notice that there's a command called wget. I think I should be able to copy this entire line and go and run this wget command. And when I run it, it says that wget command itself is not present. Let's see if I can run it on the virtual machine of Ubuntu. Oh God. Okay, I'm going to try and access the same documentation locally. I'm not able to paste it from my host machine to this computer. So there are these three commands that we have to run inside the OS. I'm going to say docs Microsoft.NET install Ubuntu, and this part of the documentation. Let's go ahead and okay, copy, control, insert. If I do shift insert and do this, it went ahead and installed the package. Now I can run this command. Go ahead and paste. So it is sudo now it is going to go and install that particular package. And now if I run the rest of the commands, why doesn't right? So notice that it is installing .NET on the Ubuntu virtual machine. If I figure out how to get wget working inside this container image, right, I can install .NET on the bash application that we started over here, right? So we are already running inside the Ubuntu container image, and we don't have much of installation here because our wget command is not working. We are not able to get to that, and that is it is planned. I wanted to show you that wget installing wget is a little tricky inside the container images, but I can always come and say Ubuntu install wget, and this thing is going to take me to ask Ubuntu. This sounds decent. And if I now run this command, okay, I don't need sudo here. apt install, it is not able to find the package. I'll have to try this second command. Or there is apt update that you will have to run. And once you run this, it generates a list of all the packages that are present on the Ubuntu um, package manager. And once those packages are available, we should be able to install wget. Now, if I run this, because its listing is updated, it could find the wget package. And with this wget package, now if I copy this and paste it here, it's probably going to paste 3 lines, right? It has gone ahead and installed the Debian package that is going to install .NET for us. So I'm going to copy this and Once again, paste installation command. These are simple. These are commands like choco install Docker desktop or 200 other installation that we have done throughout this course. And when I do this, I don't need sudo. I can get it off sudo from this command and this command and also this command and also this command. Right now, .NET is getting installed inside the container image that we created. The container image that we got, it was pretty basic. Like what we had was this, and then we gave the command bash and it started a shell. And we know how to run commands on shell to install .NET Framework. So we went to the internet, we read through the documentation, and then when we ran those commands, we have .NET on this machine. So now if I do .NET, it failed because it is unable to locate .NET SDK package. Once again, we're going to do apt update. So when you don't find a package, you can run this command. And now if I do this, it'll probably install .NET. Could not find .NET SDK 5.0. All right, this is probably the last try that I was going to give. All right, this command should have installed the .NET Framework on this particular image. What I'm essentially trying to demonstrate is that once you are inside the container image, it can act like a virtual machine. Once again, virtual machine is a wrong word for a container image, but just for the analogy, we have logged in inside this container execution inside this container, and now we are interacting with the bash and we are modifying this particular file system and we are installing .NET on it. The way to create file on a Linux operating system is you run the touch command, and I'm going to say test.txt. And if I want to type the content of this file, it does not have anything at the moment. So we have a file here. If I do ls or ls minus l, I see that test.txt is present here. It has size 0 and it is created by the root user and it has 0 permissions. Now I'm going to type exit and come out of this. Right now I'm going to do docker ps, and docker ps is saying that nothing is running. Let's go ahead and do docker run. I'm going to copy this command again. I'm going to paste this. It is the same command with which we launched a container. And now if I run this command, go inside bash and do ls minus l, my file is gone. Right? Containers, they are short-lived. What happened here? I'm going to cancel. Okay, containers, they are short-lived. In fact, if I come to a different window and do docker ps, this is the ID of the current bash container that we are into. If I do docker ps minus a and look at this output here, it is docker ps and it is created 35 minutes ago. And this docker bash, it exited about a minute ago. And notice their IDs, right? Each running container, what we were trying to establish in the in the virtualization discussion is that virtualization, it gives you a projection of the resources of the hardware that you have available. And a container also does that through cgroup and through namespaces, right? It created resources. It provided an isolation boundary to it using namespaces. And then when that application ended, it returned all these resources to the operating system. When we started that application again, we did not find the changes that we made to that particular image. The, the file test.txt, when we started a new instance, it created a new isolation boundary with a new ID. And on that ID, we were clean slate. We did not have anything. And this is another example of how modern applications are supposed to behave. There are resources that we're going to consume as we work on the application and as we use our application in production. These applications, they're going to acquire resources, but then when we are done with that resource, we should release everything back. So if in case there are memory leaks in the container image that we have created, because they are so short-lived, they are so ephemeral, all the resources, all the hard drive space, the memory that they are using, it will be returned to the operating system and your code is always going to be very clean. Your infrastructure is going to perform better. Now I'm going to show you another trick. I have copied this container ID, which exited about a minute ago. I'm going to copy this and I'm going to say Docker start and give this ID. Then I go inside. And now if I do Docker PS, I see that there are two container images and notice the time difference. It is saying that it was created 19 minutes ago and the other one is created 2 minutes ago and it is giving some funny names to it. They are auto-generated names. You can influence that. So far, we had been using Docker run command. Let's go ahead and look at the Docker exec command. Now I'm going to do Docker exec. And this time I'm not going to give the image name that we were giving all along, like hello world or busybox, Ubuntu. This time I'm going to use the container ID and notice the command that I'm using, it is exec. And exec command is once again going to work at this level, right? But exec, it requires that your Docker container is already running. It is not about the exe file, it is about the process, right? Docker exec is going to let you interact with what is already in memory and it is running on the operating system. As against the exe, Docker run, it picks up an exe from somewhere and it creates a process out of it. But then once the process is created, if you want to go inside the process that is already created, you will use Docker exec. So I'm going to do Docker exec, and this time I'm going to run the ls command, right? And notice that the test.txt, it is present because we connected to the image that was already created, right? And our changes are modifications that we made to inside the container image, they are retained for us. So if it is present inside the Docker ps -a command, you can go back, pick up the container ID, and you can run the Docker start command. And this start command is going to bring it back along with all the changes and modification that you have done. And the only change I wanted to show you .NET, but then because we could not install that, we are seeing test.txt. Now I would probably want to do more. I'll do Docker exec and instead of ls, I'm going to do bash here. And when I do bash, it doesn't do anything. And the question is why, right? It probably ran for a little while, but then it didn't do much because I did not provide the -it option. If I want my keyboard and my monitor to be associated to a program that is going to require it, you are going to have to pass the -it flag. When I do that, and when I hit enter, I have launched a bash here. I have launched a shell. Now, if I do ls, the output is still the same, but I am from within that machine. It is like doing a remote desktop to a container, to a virtual machine or to a remote machine. right? We are inside this machine, and once again we have all those options of running .NET because .NET is not installed. It is not going to show you any command, but we can probably wget was something that we installed. So wget is working for us. apt is working for us. Through this, we will be able to make modification to the application. And good that our demo failed, that we are not able to install probably in this window, that we are not able to install the Docker container image, right? Good that it failed because this is where Docker becomes so interesting. Going back to this image, right? We don't want to manually install everything. Remember our discussion from as a first point for today, that developers and QA and deployment teams, they are always going to be, they're always going to have some form of tension that what you are doing on your machine is not working on my machine. And that happens because when developers try to write code, build application, get the requirement fulfilled, they went on the internet and as part of their research, as part of their day-to-day activities, they install multiple things on their dev machine, which is only specific for their development computer, right? It is not present with test and deployment teams. And because it is not present, because there is a difference between two type of machine, they are not going to work on their machine. And the answer that we are trying to talk about since the beginning of this session is that we are going to give the machine on which this application runs to all the environments, right? And to do that, we are 99% of the cases, we are going to avoid statements like this, apt install.net. We are not going to do this. We are going to instead rely on Docker Hub. So once again, I'm inside Docker Hub. And because we are creating a .NET machine, we are going to search for .NET. And now if I search for this, .NET True, I'm going to search for official images. I'm going to search for .NET 5. And this image is by Microsoft. I think they should work. So it is .NET and ASP.NET Core. And now if I look at this file, better Docker Hub .NET Core. All right, so I am in the same image again. Official image for this. I was looking for that Docker pull command here, but I'm not seeing it. All right, so you remember discussion from our .NET section that there are two things that you have. One is .NET Core SDK. SDK is for developers. And then there is another machine, which is .NET Core Runtime, and Runtime is for production environment. SDK is going to give you option of .NET New, and then you can create a new project. The runtime is only going to take that DLL file and it's going to execute. Runtime are going to be smaller. This repository has moved to .NET/SDK. That's why. All right, and now I finally got that command. So Docker pull. I'm going to come here and I'm going to exit out of this. I'm going to do Docker PS. Now, now that we are here, let's go ahead and look at two commands. Docker PS and not PS. I'm going to do Docker stop. When I do this and do Docker PS, that image has kind of gone. But I can do Docker start, paste that container ID, and bring it back again. And if I do Docker PS, it is that same image with all those modifications. It is going to appear in this result set again. Now, another command is Docker kill. And if I give it an ID, right, I don't know if I can bring back, a program that has been killed. So it is 9133FF, this image. Let's see if we can do Docker start and paste that image ID once again. Okay, so The difference between stop and kill command is stop command is going to generate an interrupt at the hardware level that the container image, the program inside the container image can listen to, can capture, and do some cleanup activities like commit all the transactions, do some cleanup, send notifications that I'm dying, or stuff like that. But then Docker kill is not going to give any chance. So Docker stop is a little slow. It gives probably 10 seconds window before it terminates the application. Docker kill is unforgiving and it happens instantly. And if you remember um, microprocessors, um, like you must have seen these two signals at the 8086 processor level. Sigkill is going to immediately terminate the process. Sigterm is going to generate an interrupt that the application can handle. And I am guessing that Docker stop and kill, they use these two signals at the hardware level that is going to send signal to the programs and they are going to handle it differently. So we are clean now. We have stopped all the running containers. We are not. Let's go to that. All right, now we don't have anything running. I'm going to do Docker pull, and this name is so complex that I'm simply going to copy this, right? And if I hit enter now, it is pulling the image, and notice that this time, earlier we have seen like only one line and it is pulling from the system. This time it is pulling multiple layer. And this is one of the Docker advanced concept. If we are not able to get to it today, we are going to talk about it tomorrow. But it is as part of one Docker image, it is pulling different layer. And all these layer, they are stored this way for efficiency that you don't want to have multiple um, layer repeating across different type of images. I'm going to explain that when we talk about Docker layering. But for now, I'm only interested in .NET. I want to see .NET SDK running inside um, a Docker container. So with everything pulled, right, that image is now available. Now, if I do Docker run, I need that image name. So I'm going to do Docker images. That image we pulled is this one here. If I do Docker run and provide this command, it is not going to do much, I guess. Right? It did not do anything. It started something and then nothing happened, right? Because we want to go inside the shell. And what do we need for going inside shell? We need an interactive session of the output and the input. Once I run this command this way, once again, this shell looks exactly like the Ubuntu bash command that we ran some time back. But if I do ls this time, no difference. But if I do .NET this time, right, there's a .NET image that is already created. If I do .NET -help, it is going to give me all the SDK option. Remember seeing this on my local machine. So this is my computer. I'm on C drive. If I do ls, you're going to see my folder structure. If I do .NET here, I am getting almost the same output, right? If I do .NET new hyphen .NET new hyphen help, I'm forgetting commands, man. If I want to create a new project with hyphen name, I can give it a name and I'll have to give it a template as well. So let's go ahead and do .NET new MVC application, and I'm going to say hyphen name MVC demo. If I hit enter, it is provisioned a .NET Core project. If I do .NET code hyphen MVC demo, right, it is going to open up this folder structure, and I can go about doing my development work here. I trust this folder, and my MVC project is created through command line. Right? Look at these files. I'm going to do something very similar inside Docker. So this is the .NET Docker image. Notice that there's a root at the rate and a container ID. If I do .NET new MVC hyphen hyphen name MVC demo container, right? It is letting me do development inside a container image. Remember creating test.txt file? Now we are inside the container. We have done remote login using -it bash. We are already inside it, and our project is also created. Now, if I do ls, I'm going to see a folder structure, MVC container demo. If I go inside the MVC container demo, I see all those files. If I do ls-l, my csproj file is here, controller folder is here. The way to identify folder in Linux is look for this word here. If you see D, it is a folder. So there's a controllers folder, model folder, there's a views folder, there are multiple files. Everything is exactly the same. If I do cat app settings.json, I'm going to see the same JSON file that I would see here, right? But we are on that machine, we are inside the container. At this point, I think I can show you another command. So let's go ahead. I think this is the container ID ends in E26. Screen clear. If I do docker ps, it is the same ID that we copied from the other screen, root at the rate container ID. If I do docker exec is for existing running containers, and I do IT and I do bash. I have done two logins inside the same container, one from this side and one from this one here. Okay, give me 1 second. I can now build the Docker application. Docker, not Docker build, it is .NET build, and it's going to build the current folder structure. It is doing all the project restore and pulling packages from NuGet. Once those are created, that MVC application is created. Now, I don't have an option of doing VS Code here. So I launched code with this, but then code is not a command. It is not going to open up things on your computer. And this is where the other Docker command called docker cp is going to come in picture. So let's do docker ps. We know that this is the container ID. If I do docker cp and do -- help, it is going to show me how I can copy files from my local host computer inside Docker. And it's saying that the command is docker cp. So let's go ahead and paste that. There are multiple options, and then it is asking for a container ID. I hope that if I put this, it is going to work fine. And let's go ahead and create a folder on C drive. Demo files. So I've created this, excuse me. So I've created this text file, hello world, and I have copied it inside this folder structure. So there's a folder demo files inside C drive, and let's go ahead and see if we can copy that / demo files. And if I hit enter, it is saying it requires at least 2 arguments. Probably there's a hyphen in the end. Copy files and folders between a container and the local file system. Use hyphen as a source to read a tar file. I don't know if this will work. Must specify at least one container resource. Let's go ahead and do it differently. And over here, I'm going to paste the container ID. exactly 2 arguments. Okay.
I can see that in the option it says container ID and then column and then source and destination usage.
Um, so in the usage, this part here, this line.
Yes.
So I did Docker CP, and then over here it is okay. I don't know if it is container or container ID. So are you saying that I don't mention this ID here?
Yeah, maybe container image could work here, but
Yeah, you know what? Let me just go ahead and do Docker CP example and Docker CP example. Let's see what we have in the documentation. So it is Docker tar. All right. Docker CPU, once again, the same thing that we are seeing, extended description. The source path specifies a file and it ends with slash dot. I think I will have to tell it the folder where I want the file copied. At least the source container. All right, no worries. This Docker CP command, if you play around, you are going to figure out that demo files and then put a dot here. No such container path. I sometimes get confused between these slashes. All right.
the image name, just one last try.
Okay. So I type Docker CP and then image name this.
I was thinking of the image MCR and dot Microsoft, but maybe let's try
Okay.
this.
Okay. So I'm going to give it a try, but it is not going to work. It'll definitely require some form of container ID.
Okay.
Stop flow Docker. All right. So the command should look like this. So I'm going to do dot slash because I'm in the root folder. I'm going to see demo files, right? And then I'm going to have to specify the container ID. So then docker cp dot slash demo files and space, then the container ID. And inside the container where I want it pasted, I want it the root. So I can probably live with this, or probably I can give it, say temp, or probably temp already exists. I'm once again going to call it demo files. And if I hit enter, now it has gone through. So the two arguments were the local file, relative path, or probably I can do C drive as well. Then the container ID and colon, and then the destination folder. So let's go ahead and see if the folder structure is created and I see Docker files. And if I do ls demo files, it is going to display that test.txt. And if I do cat demo files slash test.txt, it is the hello world from our notepad, what we created here, right? So we are transferring file between our local machine and the Docker container image. So we have we have created an image. We have figured out how to log into that machine and how to interact with that machine, how to do multiple installation, and we also figured how to connect to 1 second, how to pick up the images from Docker Hub. Because our course was focused mostly on .NET, I picked up the .NET image. But then if you want to do Angular, you will have to pick a Node image, right? I don't know if there's an image for Angular. Let's go ahead and search for Angular. All right, and Angular is available over here. I don't know if it is a good enough image, but then if I were to do Angular development, I'm going to pull a Node image. If you don't like installing MySQL yourself, let me show you why I don't like this installation. I'm going to search install MySQL on Windows. And then as soon as I go to the home page, number one, I'm presented with 2000 different options, right? I don't know where the installable files are. I don't know which file to download, like a zip archive with no install, right? There are multiple documentation that I have to read through before I can start I can start putting MySQL to use. And honestly, what I want to do with MySQL is I want to do DDL and DML, like create a database, interact with the database, insert values in table, and I'm good with that. Why should I be bothered? I should be bothered about figuring out which version I want to install. But there are hundreds of other options, right? And you don't want to focus on the infrastructure things. You would want to focus on the activities that you want to do, and that's where Docker becomes so handy. All you have to do is just search for MySQL, pick up an image, and if you have a specific image requirement, all you have to do is I'm going to hit Control D. It's going to kill the command. And if I do Docker pull, and if I wanted version 5.7, I have to enter 5.7 here. If I don't specify anything, it is going to get the latest version. But I get the flexibility of having applications running on my machine without doing any double click, single install, and reading through multiple documentation. The creator of these technologies, they have gone ahead and they have provisioned the infrastructure required for building our application, right? And our job as developers is limited, restricted to figuring out how to how to consume these services. So I'm going to copy this, I'm going to paste it over here, and there is an option of creating an environment variable with -e and specifying a root password. I'm going to mention my super complex password here, password at the rate 123. And notice there is another option here, hyphen name some SQL, and it is specifying -d. -d is detached mode. It is going to start in the background and we are not going to see any output. So when I run this command, it is saying that, okay, so tag is not going to work. I'm going to have to say MySQL, and it already started the server. Now I can do docker ps, and I see that MySQL image is already running. And notice that -name gave me an option of selecting the name that I want, some MySQL. Now I can do docker exec because I want to interact with bash. I have multiple options. I can give this container ID or I can use this name as well. And if I do bash, and I have MySQL running here. Now it is complaining that root is not provided with an option, but then if I do -p and probably hit enter, it is going to ask for a password, and I'm going to enter exactly this password, password at the rate 123. And I have a MySQL installation done just like that, right? You don't have to go anywhere, download anything. It is going to pick up images from the internet, and it is going to have everything that you require. Now, if I say not use, show databases or database, I don't know, databases, I think it's plural, databases. All right, it is showing me that there are 4 databases that are already present. If you want to create a database, you have to give create database and say MVC demo, right? And your database is provisioned just like that. If I do show databases, the database is added over here. You can say use MVC demo, and you are already inside the database. Now, if you do show tables, there is no table, and then you can run a command, create tables and create table, I guess, and specify the table name, say employee, and then write down the rest of the SQL script, which is going to create that table for you. So development experience with Docker, it improves a lot, right? So we have crossed our timeline for today. Let's go ahead and call it a day. And tomorrow we are going to do some more .NET programming inside Docker and try to build a decent example of MVC application. All right, thank you so much.
Thank you.